Namaste, welcome to today's session at Studium. Today, we're going to talk about a very important and interesting topic, that is combustion and fuels. So let's get started. Combustion. What is combustion? Burning of any substance is defined as combustion. Combustion is defined as a chemical change in which both heat and light are produced at the same time in the presence of oxygen, and the composition of substance is also changed. If a question arises, why is combustion defined as a chemical change? As we all know that chemical change is a change in which new substances are formed, properties does not remain the same, and it cannot be reversed by reversing the condition. The same thing happens with the combustion. For example, burning of coal or a paper. If we burn a coal or paper, what we get result is ash. And ash cannot be reversed back to its original state, that is paper. So that is why we use the term chemical change in the definition of combustion. Okay. In chemical change, the change that takes place cannot be reversed. For example, burning paper converts it into ash, and ash cannot be changed back into paper. That is, its physical change is a temporary change and can be reversed, and no new substance is formed. For example, if ice melts, it can be reconverted into ice without forming any new substance. Burning of coal also gives us energy in the form of light and heat. In this process, the composition of new substance gets changed. Few more examples. When charcoal burns in air to give carbon dioxide and heat. So charcoal is a compound of carbon. So when we burn carbon in the presence of oxygen, what we get as a product is a carbon dioxide and heat. Now, when methane burns in air and forms carbon dioxide, water and heat. So when we burn methane in the presence of oxygen, what we get as a product is carbon dioxide, water and heat. Substances can be divided into two parts on the basis of combustion. These are combustible substances and non-combustible substances. Combustible substances. Substances that easily catch fire are called combustible substances. For example, kerosene, oil, petrol, etc. Non-combustible substances. Substances that do not catch fire easily are called non-combustible substances. For example, glass, stone, etc. Few examples of combustible substances. These are wood, coal, LPG, kerosene. The full form of LPG is liquefied petroleum gas. You all can see it in your homes. Few examples of non-combustible substances. These are sand, stone and water that do not catch fire easily. Supporter of combustion. In this topic, we will talk about the supporter of combustion, that is oxygen gas. We cannot imagine combustion without the presence of oxygen. So let's start. Step 1. Take a flask and wooden base. Put a candle on the wooden base and cover it with a flask. In this situation, flask is open from which air goes in and out. As we know that air contains oxygen, carbon dioxide, nitrogen, etc. Therefore, it means oxygen gas is inside the flask, due to which candle is burning. In the second step, take another flask and wooden base. But the flask is not open from the top. The top of flask should be covered with cardboard. The air cannot come in from the outside. The air which is inside the flask is used by candle for burning. But if there is no air, that is oxygen, inside the flask, candle will get extinguished. This is due to absence of oxygen because we cover the flask with cardboard and the oxygen which is present in the flask is already used by the candle. In the step 3, the chulhas used in villages have gaps. These gaps are left between logs of wood for better supply of oxygen. If the oxygen does not enter, proper combustion will not occur. Therefore, we can say that oxygen is a supporter of combustion. So here the conclusion is that oxygen is the supporter of combustion. We can't imagine combustion without the help of combustion. So as you can see in this image, in the experiment in the step 1, it showed that take a flask and a wooden base and put the candle inside the flask, but the top of the flask should be open so that the air can get inside the flask and the candle remains burning. But in the second step it said that take another flask and a wooden base, but the top of the flask should be covered with a cardboard so that the air does not enter the flask and the candle will stop burning. But it will not stop burning instantly. It will take time because the oxygen which was left it will be assumed by the candle for burning, so it will not stop instantly, but after a meanwhile of a time or after some time it will stop burning because there is a lack of oxygen or the lack of air, which is very important in the process of combustion. Now here we will talk about ignition temperature. It is the lowest temperature at which a substance catches fire. It is different for different substances. For example, kerosene oil. If a matchstick is burned in a room where kerosene oil is placed, kerosene quickly catches fire. Alternatively, wood does not catch fire on its own at room temperature. So here the wood does not catch fire on its own at room temperature. But if wood is heated a little, it catches fire. The only difference between both of them is that kerosene catches fire quickly, but wood takes time to catch fire. The only difference between both of them is that kerosene catches fire quickly, but wood takes time to catch fire. Now here we will talk about inflammable substances. Substances which have very low ignition temperature and can easily catch fire with a flame are called inflammable substances. For example, petrol, alcohol, LPG, CNG, etc. Now here we will talk about calorific value. It is amount of heat released when 1 gram of fuel is completely burned in sufficient supply of oxygen. It is measured in kilojoules per gram. For example, hydrogen gas has the highest calorific value. Here is a table about the calorific values of some fuels. So let's discuss. Wood. The calorific value of wood in kilojoules per gram is 17. Okay. And the calorific value of kerosene is 48, biogas 35 to 40, coal 25 to 33, diesel 45, methane 55, dung cake, that is gobar, is 6 to 8, LPG, that is liquefied petroleum gas, 50, hydrogen is 150. And the highest calorific value of any fuel is hydrogen. Hydrogen has the highest calorific value, and the least calorific value is dung cake, that is gobar, 6 to 8 calorific value in kilojoules per gram. Thank you for watching a video. Please like and subscribe to our channel, and don't forget to hit the bell icon so as to get notified for the new videos we are going to upload. This is the first part on combustion and fuels, so stay tuned with us for the next part. Thank you.